Hello, everybody. Uh, I'm solving LeetCode 2583, eighth largest sum in a binary tree. It's the 22nd of October today. This is the problem of the day. It looks like I've solved this before. Uh, must have been a while back. I don't think I remember how to solve this anymore, which is fine. We'll try to come up with a solution again. All right, let's get into the question. So you're given the root of a binary tree with a positive integer k. The level sum in the tree is the sum of the values of the nodes that are on the same level. Okay, which just means if you're on level 1 here, so your sum would be 5 because you just have one node. If you're on level 2, which would be 8 plus 9, that would be 17, and then similarly so on and so forth. All right. Return the kth largest level sum in the tree. If there are fewer than k levels in the tree, return -1. No, there are two nodes on the same level if they have the same distance. All right, yeah, that makes sense. Um, let's look at this example. This makes sense. Yeah. On level 1, you just have one node, so the sum on that node is just 5. On level 2, it's 8 plus 9, so that's 17. We got 2 plus 1 plus 3 plus 7, and that's 13. And then in level 4, we have 4 plus 6, which is good, which is fine. That makes sense. This is also a binary tree, which just means each node is going to have only a left and a right child. And yeah, so the number of nodes on each level, there's a formula for it. It's given by 2 to the power n minus 1. So you could just plug in values here. So if you want the maximum number of nodes, if you want, wait, the max number of nodes on level 1, that would just be 2 to the power of uh, 1 minus 1, which is 2 to the power 0. That is just 1, which makes sense. Since we see that on level 1, we always have just one node. And then if you do this for level 2, we just change this number here. You get 2 to the power 1, which is 2. And then on level 3, it would be 2 to the power, right? This would be 2 to the power 2, which is 4. So at max, you could have 4 nodes on level 3. At max on level 2, you could have 2 nodes. And level 1, you just have one node. Okay. Hmm. This is 1. That's 2, null, and 3. Okay, they had to specify null because uh, since node 1 needs a left and a right child, we only gave them the value. The input gives us the value for just the right or the left child, but not the right child. So it's just null here. And then this node 2 has the left child, just 3. And we are not considering, we are not inserting any more nodes after this. So this is just a fine input. Okay, k equals 2, so we get 17, 13. The answer is 13. Okay, 17 is the largest, and then the second largest is 13. So that would make sense. All right, constraints. All right, this is fine. Between 1 to n. Uh, okay. If there are fewer than k levels in the tree, but okay, so I don't have to check for it because the constraints say that the k is always going to be less than n. If k was more than n, then I would have to return -1. But since the constraints say that I don't have to do it because it will be always less than n, I just don't have to check for it. So this -1, not really important for us right now. All right, how would I go about doing this? Well, the first thing that comes to my mind is with the formula. You could traverse the whole binary tree in BFS way, breadth first search. So you would go to level 5. I mean, let me just write it out here. All right. Sorry for the weird cut. My tripod just fell over. All right. What was I saying? So you would add these numbers. I mean, I would traverse them in BFS order, and they would look something like this. So we go 5, and then we would have 8, then 9, then it would be 2, and then 1, and then it would be 3, 7, 4, and 6. We get this array, and then we could also create a different array, and this would just store the sum on each level. So I can figure out, hmm, that level 1 has just one node in it. So I could just go, okay, this is my starting and my end. I need the sum of all the elements in between those values. So I would just store 5 here. I would see that, okay, I'm on level 1 now. Sorry, level 2 now. So I would take these two nodes and then I would sum them up, put their answer in here. I would get 17. I would go again. We need 4 nodes this time. So then these 4 would come along. It would give us 13. And then finally, we reach the end on level 4, um, which could hold 8 elements, but we don't have those many elements. So we just get 10 here. We just sum up how many ever we have. And then you could just sort these. So you would get 7, 5, 10, 13, and 17. And maybe we are finding the largest one, right? So do it in a reverse order. So it would be 17, 13, 10, and 5. And then you could just do you could just do array of k minus 1. Yeah. And then that would give us 13, which is the right answer for this example. All right. This makes sense. This seems pretty basic. You have an integer pointed for the right, pointer for the left. We have 3 types of constructors. Empty constructor. We got something with a value. We got something that, all right. Yeah, I don't need this. I think I'm okay. Uh, Hold on. This was val. Okay, so I do need to remember that. All right, cool. So I would write some sort of um, do we need 2 arrays here? I mean, this seems unnecessary. This is just uh, of and time space complexity. I think we can avoid it. I think we can just do this on the fly. You just keep track of what level you're on. Uh, maybe in BFS itself, when I write the recursive code, I think I can figure it out. But we'll just let it be there, just so that I can visualize it better. All right, so let's start. It's gonna be a void function. It's gonna call it recursive. Uh, hmm, how would I store these? I mean, a dynamic data structure would make sense here. I could go for a list, an array list of, okay, this is long. We just call it array list. Yeah, that makes sense. Makes sense. This is fine. So, okay, yeah. Here we would need this array after all, because we would be inserting values into it. So array list long r. I would need to know what level I'm on, and uh, I would need the node, right? I would need the node to make sure I can do all my value operations and whatnot. I'll just call it node. Cool. Uh, hmm. Uh, if node is null, which means we have reached uh, the last the last node here. I mean, the recursive code, if you try to go a level beyond this, it would just be null. So we would just return from there. And that would be my end case. Hmm. So um, I need to create a level, right? So if my uh, level is equal to array dot um, size, this is array dot size. So at the start, I don't have any elements. So if my level is start, I would have to create something, right? Uh, hmm, this would be array dot add um grad 0L. Yeah. The reason why I'm adding L here is just so that it's a long because we need the output has to be long at the end. So I'm just adding L here. And this is how you do it in Java. And this is also just a single liner, so I don't need these brackets here. This would make sense. And now we would add uh, the recursive code, right? Hmm. All right. So now that we have added a level, we have to append the value at this node to the correct whatever it is. So array.set, and then I would do what index I'm at, so a level. And I would also have to add um, array.get level, and I need to add node.val. Yeah. So this just means if I'm on node 8 here, I would see if the level and my array size are the same. Uh-huh. I would just add this level here. This is just to see, since we have 0 here when we created this new level, um, I'm just setting the level again by getting whatever the current value is, and then appending whatever the value I get at this node. So at 8, this would be 8 here. Okay, yeah. Hmm. Okay, I think this makes sense. I hope this makes sense to you. I'm not able to explain it to you properly. It's just that every time we go down a level, uh, it initializes the sum for that level by 0, and then afterwards when we go through elements or go through nodes at that level, we would just add them, and then if we encounter one more node at the same level, we would get the previous value of it and then add the new value to it, and this all together at the end would just give you the sum for the whole level. Yeah, that makes sense. And now we just need to call this recursive function. uh, this is array, we go level plus 1, and then node dot left, and we call array level plus one and node dot right. This is a recursive code. So when I'm here, it gets whatever the value I need, it stores whatever sum I have, and then it calls this thing and it calls this thing, and then these things will keep doing their own thing while all the way down till I reach null, and at which point it would just return me the value. It would just exit out of this function call. Yeah, that's fine. Hmm. I would also have to sort these in somehow. Hmm. Let's just call the recursive function for now. This would be at level, uh, so I'm at R, I'm on level 0, and uh, root is my main node. So this would be that. And now I just need to sort in reverse order. So R dot sort, and then I'm just going to use collections dot uh, reverse order. This would just print the whole thing in reverse order, and then I would just return array dot get k minus one. Let me just comment these out. That makes sense. Hmm. Yeah, let me run this. Okay, yeah, let's submit. Oh, what's that? Print is three out of bounds. Okay, so I mean, I guess we would have to do this. These constraints just mm, they're just not right. We would just have to add an if condition. So if uh, k is greater than uh, array dot size, we would just return minus one. Hmm. Yep, there we go. Not the fastest solution I've ever done. I mean, still 44 ms in a while. But yeah, this was LeetCode 1 2583. Thanks for watching, guys. See ya.